Factory 5-step method by Dan Williams. And Alyssa's going to help. Okay, step 1. GCF. Does everyone remember what a GCF is? Greatest common factor. Okay? Greatest common factor. GCF. Everyone's writing this down, right? Because this is like, I already made this really important. Told you, important. Okay, next color. Okay, this is when colors become really helpful. Next color. Okay, parentheses. Star. Variable. Variable. Like an X or a Y or a Z or a T. Okay? Parentheses. Star. Variable. Okay? The star is just an asterisk. I was creating this thing, and I was trying to take it from a 12-step method to an 8-step method, and the 8th step was still struggling with the stadium students. This was back in like 2000 or 99, at the end of 99. And I'm like, you know what? I can turn this into a 5-stepper easy. And I'm looking at the wall, and there's a big asterisk with something next to it. And I'm going, star variable. Yeah. Pulling it right off of the wall. I can still see it in my brain. From what is that, 16 years ago? Star variable. Okay? I'll tell you what a star is later. Okay? Second. Third. Another color. Signs. Signs. Okay? Signs, like plus or minus. Signs. Okay? Fourth. Brown be okay? Brown okay? Should I use a different color? Orange, brown? What do you guys want? You guys can use blue instead of brown or whatever. Okay. Product and sum. Okay? Yes, sir. Oh, thank you. Product and sum. Okay? Product and sum. That's pi and sigma to you guys. Right? But I'm going to teach you, right? Because in calculus, we use this thing called a summation. That's this guy right here. In calculus, we use something called a productation. That's this guy right here. Now, I never even learned about productation until college. When the professor handed out these series they couldn't solve. I solved it in took me about 3 days, a week. And he's like, what did you do here? And I created something called a subfactorial. Right? And it was within my summation. And it's like, used all the rules. And he's going, what is this? And I'm like, well, I used all the rules. It's a factorial, it's a sub, and it's within the summation. That's all I know. He's like, I don't know how this is, what this is, but it works. So they took it back, and his professors back at the university worked on it for about 2 months until they figured it out using productation. My solution was this big. Their solution was 3 pages. I thought mine was better, but they didn't understand it because it was different. I used a different notation that they were used to. So I like to show you guys the stuff that you will see when you get into higher math. Pi, sigma, but we use them as summation. So I use it here as a sum and a product. Product like multiplying, right? Sum, adding, subtracting. Product, multiplying, dividing. Okay? Alright, and then 5, the 5th step. Star cleanup. Okay? This is really an important step. Okay? Are we recording? Good. Oh crap. Running low on time. Okay. I'm not going to rush it. We got this. So this is factoring. This works with anything. Okay? And so I'm going to use a number. Let's use 6x squared. Yeah, why not? 12. Let's go with a minus. And what is that? That's 60, 72. 72. And an 8, that works. Maybe 1? No, but no. Yeah, 9 and 8.
Don't.
Maybe 1. Okay. And so, why not a minus? And then I want to change this up a little bit. So we're going to make this 18x squared minus 3x minus 36. Okay? That's what we're going to start with.
Oh, so it's not going to be that X. Wait. Did we change it or did we leave it last?
We can change it because we're going to get back to it. I'm going to show you every step to the 5-step method. That's why I had to make this. Alright, the first step is GCF. Okay? The first step is GCF. So I want to know a number that goes into, or letter, but something that goes into every one of these.
Is that a B?
Huh?
Is that a B?
A B? No, that's a 6. That's a 6. 36. So what number goes into 18, 3, and 36? What's the GCF of those three numbers? What number will go into 18, 3, and 36? What number goes into 3? 1 and 3, right? Good. Now, does 3 go into 18? Now, what's the trick for 3s? You guys remember? What's 1 plus 8? Come on, guys. 1 plus 8?
9.
9. Is 9 divisible by 3? Then 18 is divisible by 3. That's the trick for 3. If you don't remember, this is a good thing to remember. And here, this is really crucial that we start learning these 3 tricks. There's 3 tricks. 2, is it even? 3, do the numbers add up to be a number divisible by 3? 5, is it end with a 0 or a 5? Those are the 3 tricks I ask you to memorize. I don't really ask you to memorize a lot. Okay? Alright, so 3 does what's 3 plus 6? 3
Plus 6.
9. Is 9 divisible by 3? Yeah. So is 36. So 3 goes into all of these. 3 times what is 18? 3 times any? Yeah. When when you're crab boating, 6, 1. That's the difference, because you can only use hand one because you got to hold on with the other hand. Never mind. Nobody watches this show. Okay, so 6x squared. 3 goes into 3 how many times? 3 goes into 3 once. Good. And 3 goes into 36. Well, 3 goes into 3 once. And 3 goes into 6 twice. Okay? That's your first step. So I have 3 times 6x squared minus x minus 12. And see how we came right back to that one I created to begin with? Okay. Okay. All right, next. Green, right? This just comes down. This just continues to come down because that's your factor. Okay? Now, this gets split up into 2 pieces. Okay? We're going to make it into 2 binomials. Okay? Good. All right? Now, this is your star, Bobs. This is your star. That first coefficient. And this is your variable. So you're just going to go 6x. 6x. And then I got to remind myself. There's a star here, and I got to clean that up later. Okay? I have to clean that up later, so I remind myself. Don't forget the star. Okay? The reason is, what's 6 times 6? 36, right? It's not 6, is it? These two have to multiply to become this. I have an extra factor of 6 in there that I have to clean up later. Okay? Now, the reason I do that, it makes the job easier. Has anyone ever laid down a linoleum floor? Right? When we lay down linoleum floors, you know, what we would do is we would throw down the glue, and then you gotta grid it off, right? And you grid off all the glue so there's a certain amount of glue on the floor, right? With a special tile grid. Okay? And then you lay it down. And as you push it all down, you push it with a roller. Like we use roller pins, but you can have these big fancy rollers if you have the money for the tool. Right? Or you just use a rolling pin. Right? And what happens is the glue squirts out the edge. Right? Then what do you do with that glue? You wipe it up. And why is that important? Because you want the same exact amount of glue throughout the whole linoleum floor, or you'll end up with bubbles. And you don't want bubbles because they'll wear a hole in the linoleum. Okay? And then you got to come back and replace it. Okay? So that's the whole key. You squeeze out the glue, you put a little bit extra down so you can clean it up after. It makes it for a quick job. This is exactly the same thing. I threw it a little bit of extra so that the numbers are neat. Okay? So it's really important. So it's simple. Just bring it down. Right? That's all we're doing. We're just bringing these down. That's it. Okay? Now, are you using different color pens? Because if you are, you can continue with this. If you're not, you need to make another layer. Okay? So when we go to signs, right? If I'm using 2 colors of pens, I can say, okay, I'm bringing down this sign. And that sign goes right here. But if I'm using the same